Hello again, everyone, and welcome back to Programming in Access 2013. My name is Steve Bishop, and today we're going to be continuing our series on VBA, or Visual Basic for Applications. More specifically, today we're going to talk about arrays and multidimensional arrays and some of the functionality that we can use arrays for. Alright, so I'm going to hop back into my database here. I've got a Go button, and on my Go button I've got some code back behind here. And I've set a breakpoint, and the way you set a breakpoint is in the little margin here. You just click next to one of your lines of code, and that will set a little red dot here and highlight the line in red. And essentially what a breakpoint does is it sets a stopping point in your code so that you can inspect your code and look at the different values and kind of walk through your code to see line by line what's going on. So I'm going to go ahead and go here and click on the Go button, and you'll see that we have stopped at that breakpoint, and it's now highlighted. Now, just an FYI, the part that is highlighted has not yet been run. All right, it is the next part that is going to be run. So when you run across values that are in the highlighted section, they have not actually been calculated yet. We'll get into that in just a little bit, but essentially that's how you set a breakpoint. You can set a breakpoint among almost all the lines on here. You can't set a breakpoint next to any dim statement. You can only do it on certain lines in your code, such as a redim or when you're doing value assignments and such. Alright, so I've got a breakpoint here. Now the way you step through the code and you go line by line is you can press the F8 key. You can also add a button up here in the toolbox, but I just prefer to go ahead and hit the F8 key. So I'm going to hit that, and we'll see that the first thing that we come to after we've got our breakpoint is that we're assigning the value 1 semicolon 2 semicolon 3 in our text variable. All right. So basically, it's what we call semicolon delimited. All right, where we're taking and separating each value with a semicolon. This is a very common practice when you're storing information, such as in a text, like a text file. Something that's very common is called a comma-separated values, all right, or a CSV file. But in this particular case, I'm going to use the semicolon to separate out the different values in my text string. All right. Now I'm going to go ahead and dim an array called numbers as a string, and you'll see that I call it a dynamic array. A dynamic array is one where you have not set the upper boundary or lower boundary of the array. It's kind of malleable. You haven't fully formed it yet. It doesn't have that upper and lower boundary yet. If I gave it a subscript value of, say, like 6, right, like that, then it would be a static array, because we basically said, I know what the upper end of my array is. It's going to be 6. All right. Now, another thing to keep in mind with arrays is that they are a base 0. That means that by default, the first value in an array, the subscript number, is 0. So if you're looking to assign or retrieve a value from an array, 0 would be the first number that you would use in the array to get the first value. And the second value in that array would be 1. And the third value would be 2, etc. Okay? There is a way that you can specify that in an array of where the upper and lower boundary is, and that is if you say 1, 2, say 5, something like that. Now you're setting the lower boundary to start at 1 instead of 0. And then if you tried to go look in the array at 0, you would get an error. So make sure that you understand that by default, you're going to be starting with 0 as the lower boundary, and in this case 5 would be the upper boundary. So 0 would be would be your first value, then 1 would be your second value, and etc. So for right now, we didn't have any boundary set. We didn't set any upper or lower boundary. And we need to do that when we're going to use this special function called a split function. What the split function does is it takes a text string and it looks inside the string for any particular character to separate those values by. And up here we have a semicolon delimited. So what we're doing is we're using the split function. We're going to pass it two variables, one called the text string and one that is in quotation marks, which is the semicolon. So we're going to say, look in the text string for any instance of a semicolon, and wherever you see that semicolon, I want you to split up those values. Okay? And what happens is that for each time that the split function runs into a new value separated by a semicolon, it's going to add it to the numbers array here as a new value in the array. All right? So it's going to look through the text, it's going to find one semicolon, and it's going to see, oh, there's my semicolon. So the first value, the numbers 0 subscript, is going to have the value of 1. And then it's going to go and find the next semicolon, and whatever the value was there, it sees, oh, it's 2. So in the numbers 1 subscript, it's going to add the value of 2, and 3 would be the next one. All right? So we just now put all of those values into the numbers array here, and now we're going to do a for each loop on that numbers array. And for each item that we find in the numbers array, I want to pop up a little message box just to show you that each individual item in the numbers array has a single value now. So 1 is the first value, 2 is the next value, and 3 is the last value. Now the opposite of a split function is the join function. Now the join function, we're going to take the numbers array, and we're going to take each value in this numbers array, and we're going to combine them together. We're going to put them back into a string variable here, but we're going to take each value from the numbers array, and we're going to separate it out with a colon. So we're basically swapping out this semicolon, and we're going to use a comma instead. All right? So we're putting all those values that we had in the numbers array, we're joining them together into one single string, and we're separating each value with a comma. And lo and behold, 1, 2, 3. All right? So that's kind of neat. Those are two of the really kind of neat functions of arrays, something that you can actually use arrays for. And the next thing we're going to talk about is the readIn statement. Now, a readIn is important because up here, we didn't really know what the upper and lower boundary of the numbers array was going to be. And now that we've created the upper and lower boundary by using the split function, let's say that we want to add more values to this numbers array, but since we already set the upper boundary of the array to subscript 2, we need to do something to raise that upper level, to raise that upper boundary. And that is using the readIn keyword. So here's the use of it. You use readIn, and then in this particular case, I'm also using the keyword preserve, and then we're saying what the array is. And then we're giving it a new subscript value. In this case, I'm giving it subscript value 4. Now what the preserve statement does, what the preserve keyword in the readIn statement, first of all, it is optional. You don't need to have it in here. But by using the preserve keyword, what you're doing is you're saying all of the values that were in the numbers array, which is what we did up here when we split it up and we split the text string and put it into the numbers array. I want you to preserve the values that are in the array and keep them there. I just want to add or change the subscript range up to 4. All right? The reason why we do that is because we want to keep those values that we put up there. But if I left the preserve keyword out and just did a readIn numbers 4, all of those values that I put in up above here would be deleted. They'd be completely cleared out. All right? So that's why I use the preserve keyword. Now, one thing to keep in mind also about the preserve keyword is that you don't want to use it as much as you want to use it. You shouldn't use it. And that's because what essentially Access has to do is take those values that you put in the numbers array and put them into a temporary array, then basically delete this numbers array, recreate it with the new subscript range, and then take your temporary array that was made up in memory and dump all those values from the temporary array and put them back into the numbers array. So that's an awful lot of work for the Access database to be doing, and that's why it's preferable that you don't use the preserve keyword if possible. But obviously there are those circumstances where you just need to keep whatever the values were up in the previous code. All right, so I'm going to redim and preserve my numbers array. I'm going to increase the subscript value up to 4. Just one other thing before I proceed, just before I forget. If I tried to redim this as 1 to 5, I would run into an error because I'm using the 0 base as my array, since I'm starting as 0, and since I'm using the preserve keyword here and it starts at subscript 0, I have to redim it as 0. If I did 1 to 5, I'd get an error. Right? Probably iterated that a little bit wrong, but I hope you understand the thrust of that. If you're going to use that preserve keyword, you've got to make sure that you're redimming with the same range. All right. So now I'm going to go ahead and redim this. I'm going to go ahead and add the numbers 4 to subscript 3, add the number 5 to subscript 4, and then I'm just going to run a little message box to show you that indeed we kept values 1, 2, and 3, and then we added the values 4 and 5 to our numbers array. All right, that's great. Next up, we have the LBound and YouBound functions, which help us determine the lower and upper bound of an array. So here I've got the LBound function, and I'm passing it the array of numbers. And what the LBound is going to return is what is the lower boundary of our subscript range, and that would be 0. Notice I'm hovering the mouse over it here. We get the little drop-down box, or the little comment box that says LBound numbers equals 0. All right, that means that the lower boundary is 0, which is the default for an array. If I hover the mouse over the YouBound function, we can see that it returns a value of 4, because remember, I redimmed it up here with the upper bound of 4. So using the LBound and the YouBound functions gives you the upper and lower boundaries of an array, and that can become very, very important when you're trying to loop through the code. And that's what I'm doing right here. I'm saying for I equals the LBound value, which is 0, to whatever the YouBound value, which is 4, I want you to take the numbers array, and whatever the value of I is, I want you to add a value of I to that subscript of I. All right? So I'm taking, like, just to go through this one time here, I currently has the value of 0. All right? We can see I is 0. So what we're doing is in the array numbers with subscript of 0, or I guess it's 1. No. Okay, there we go. I'm sorry, I'm hovering it over at the wrong time. I haven't yet set it. It's still holding on to that 1 value that we put up there before. There, that should be a little bit better. So what I'm doing is I'm taking the numbers array, subscript 0, and I'm giving that subscript 0 value of the numbers array a value of 0. And I'm moving on to the next I. So now 1 is going to equal 1. So 1 is equal to 1. 2 is equal to 2. 3 is equal to 3, and so on. Okay? So now we're going to be basically getting 0, 1, 2, 3, and 4. And again, I'm doing a join, separating out each value of the numbers array with a comma. And we get 0, 1, 2, 3, and 4. All right, great. So now let's talk about multidimensional arrays. Multidimensional arrays are great because they're, in this particular case of what I've got here, I've got basically, you can think of this as the x-axis and the y-axis, or vice versa, y-axis and x-axis, whatever you want to think of. But essentially what we're doing is we're setting from 0 to 4, so it'd be 5 values, and then we're also having, so I guess basically, might be even easier to think this is like a table, and that's why I've even named it table of nums. This would be like 0 through 4 rows, excuse me, and 0 through 4 columns. So it'd be like this. Like I'm just taking these 25 cells here, and I'm doing 1, 2, 3, 4, 5. So that'd be 0, subscript 0, subscript 1, subscript 2, subscript 3, subscript 4. And then I'm doing across by 5 as well. So that gives me a total in my array of 25 different spots made available in memory for me to store values. Okay, I know I kind of came around about that a little weird, but I hope that makes sense. I think this illustration really helps out. You can also add another dimension here. It won't let me do it right now, but you could actually add basically like a z-axis if you wanted. That's why they're called multidimensional, because you can add different dimensions of an array, and your computer will be able to hold on to it. Alright, so I've got a table of nums array. I've got 4 rows and 5 rows and 5 columns. Okay, again, because we're starting with a default base value of 0, so 0, 1, 2, 3, and 4, and then 0, 1, 2, 3, and 4 for my columns here. And what I'm doing, and this is kind of complicated here, but because I've got 2 different dimensions, I need to iterate through each one of them. So what I'm doing is I'm setting a for next code block here, and inside of my for next code block, I've got another for next code block. The first, or the top level for next, is going through the x's and going for x equals 0 to 4. So that's going to be 5 times that we're going to iterate through this code. I want you to basically iterate through this code 5 times. Okay? And then we're doing the same thing, but we're going to do it on the y instead. So this is essentially going to run this bit of code here 25 times in total. And we'll see the first time through, okay, for x equals 0 to 4, so x's value right now is 0, and y's value is 0. And you can see if I hover the mouse over those values, you can see x and y are equal to 0. So table of nums array, subscript, the first value of the subscript, 0, and the second dimension is also 0. And what I've done is I've set, just for ease of use here, I've got a string that I'm adding to the array where x equals whatever the value of x is and y is equal to the value of y. So this is just kind of a neat little way to kind of show you x equals x and y equals y in our string. Alright, so you're going to see it's the first time through, x was 0, y was 0. Now it's going to go back up to the 4, and you can see y now equals 1, so x is 0, y equals 1, and that's sort of like saying, okay, 0, 1. Okay, so this would be the cell. So the first time through, this was the cell. This second time through, this is the cell. All right. Now the third time through, this is the cell. Fourth time through, this is the cell, etc. So you can see how it's going 1, 2, 3, 4, 5, and then the next time that we go, you'll see it hits back up to, it hits this x and changes x to 1 now, and now we're iterating back through this loop again. So now x equals, oops, let me hover over the right thing here, x equals 1 and y equals 0. So we're back to, now we're down to this row. So x equals 1, y equals 0, etc., etc. We're just going to keep on going through here. I'm going to go ahead and set a little breakpoint here and run on down through. And now this is a bunch of code that I've got in here which basically opens up a table, a TBL output, and it's going to take those values that we put in up here and it's going to put them into a table for us so you can see. Oops, let me open up the right thing here. So there we go. So we can see row 1, column 1 is this cell where we have x equals 0, y equals 0. The next time through, y equaled 1, but x was still 0. X is 0, y equals 2, x is 0, y equals 3, x is 0, y equals 4, and then down here x equals 1, y equals 0, etc. So you can see the pattern. This is how we get multi-dimensions. We got one dimension going vertically, one dimension going horizontally, and then we could have another dimension going in the z-axis, if you're familiar with the z-axis. And you can add even more dimensions than that, I believe. So, all right, I hope that's a good enough explanation. I know there's a lot going on there. Arrays are kind of tricky things, and I don't know if you caught this previously in a message, but in one of my prior videos, I'm not really an array guy. I don't really find them particularly useful, but that doesn't mean that you won't run into some uses during your coding. You may find them to be fascinating and work perfectly for whatever it is that you need them to do, so I just kind of wanted to show you what they look like.